Have you ever pondered about the critical role that predictive maintenance plays in missile systems? Well, it's high time we shed light on this vital aspect. Predictive maintenance in missile systems is not just about fixing things before they break. It's about ensuring reliability and longevity of these complex systems. Imagine a missile system that can flag potential issues before they escalate into catastrophic failures. That's exactly what predictive maintenance does. It uses sophisticated algorithms to analyze patterns and predict future failures, ensuring our missile systems are always in top-notch condition. The cost-saving implications are also enormous. By detecting problems early, we can carry out maintenance tasks more efficiently, reducing the overall costs. Moreover, it minimizes the risk of sudden failures that could lead to severe consequences, enhancing the safety and security of our defense systems. Predictive maintenance, therefore, emerges as a game-changer in the field of missile technology. Now, let's delve into a real-life case study to better understand the impact of AI-powered predictive maintenance on missile systems. Imagine a missile defense system. Let's call it System X. System X was initially maintained using traditional methods. Technicians would perform scheduled inspections and react to system failures as they occurred. But with the complexity of missile systems and the dire consequences of unexpected failures, this approach was far from ideal. Then System X was integrated with an AI-powered predictive maintenance solution. This solution was designed to use data from sensors placed throughout the system to train machine learning models. These sensors monitored variables like temperature, vibration, and pressure, collecting a vast amount of data every second. This data was then fed into machine learning models, which were trained to recognize patterns and anomalies that could indicate potential issues. The AI solution was not just about predicting failures, it was also about understanding the health of the system in real time. For instance, if the temperature of a specific component started rising steadily, the model could predict an imminent overheating issue. This allowed for timely maintenance before the problem escalated,